The common pathway of coagulation is the final set of steps used to form a blood clot, shared in common by both the extrinsic and intrinsic starting pathways. Mastering this pathway requires memorizing a seemingly endless number of random numbers and clotting factors, which can be really hard. Like, really, really hard. So today, I'm going to show you the easy way to memorize this entire pathway from head to toe, so you'll be sure to wow your friends and family at the dinner table. Because everyone talks about complex physiological pathways at the dinner table, right? Anyways, let's get started. Welcome to the dessert bar, where just as you might expect, we're surrounded by a ton of Jell-O desserts, because Jell-O desserts are commonly found in any dessert place, right? The red Jell-O here just happens to be our recurring symbol for coagulation, since if you've ever made Jell-O before, you'd know that Jell-O is formed by the solidification of red liquid, which is kind of like how your blood clots, right? And the common setting for Jell-O should remind you that we are talking about the common pathway of coagulation. To review, in our previous videos, we covered the extrinsic and intrinsic pathway of coagulation, which are two starting pathways that eventually come together in a common set of final ending steps. These common ending steps are known as the common pathway, and is the focus of this video here. If you haven't seen our previous videos already, I'd recommend starting there and coming back to this one later. To begin, we're going to start in the back left corner, where a dad here is holding a tennis racket. But this isn't any ordinary tennis racket. No, no, no. This guy only plays with the best equipment, as you can tell by the 10 out of 10 rating on that tennis racket. Both the 10 out of 10 rating and the word tennis itself should remind you of factor 10. All of this is here to help you remember that activation of factor 10 is the first step of the common pathway of coagulation. You see, both the intrinsic and extrinsic pathways end by cleaving factor 10, which actually activates the clotting factor. Just remember that this is the first common step to making a blood clot. So what is our tennis racket holding dad doing? Well, it seems he's pouring some Super K cereal into this dessert to add some extra crunch. Wait, Super K? Isn't that Pixorize's recurring symbol for vitamin K? This Super K is our recurring symbol for vitamin K, which is here to help you remember that factor 10 needs vitamin K for activation. In fact, factor 10 is one of the vitamin K-dependent clotting factors, which will become important later when you learn about vitamin K-blocking drugs like warfarin. But vitamin K is not the only thing needed for factor 10's activation. Let's pan over to the calcium ice cream this guy's pouring the Super K into. Yep, that's a cow-branded ice cream, our recurring symbol for calcium, or calcium, if you will. This calcium ice cream should help you remember that factor 10 also needs calcium for activation. You see, the presence of calcium ions stabilizes the chemical conformation needed for activation of factor 10, which makes calcium act as a catalyst for this reaction. Afterwards, take a look at the membrane seal covering this ice cream. You know how these ice cream cups always have this membranous covering to keep things fresh? Well, the membranous appearance here should remind you of phospholipids, since phospholipids are what make up most membranes in our body. This is to help you remember that the activation of factor 10 is also catalyzed by phospholipids from a membrane surface. Now, if we shift our gaze right to the other member of this table, you'll notice a kid biting into a piece of star fruit. This 5-pointed or 5-sided fruit should help you remember factor 5, the next member of this coagulation pathway. You know, a 5-pointed fruit for factor 5. Note that factor 5 is not actually cleaved by factor 10, but rather is independently cleaved and activated by another method. To figure out what actually activates factor 5, let's touch on our next symbol. Check out how this kid is biting into this 5-pointed star fruit with his 2 front buck teeth. These 2 buck teeth are a recurring symbol for factor 2, and this picture should help you remember that factor 5 is actually activated by factor 2. Factor 2 will actually come up downstream in this pathway, but for now, I want to note that the activation of factor 5 by a downstream clotting factor creates a positive feedback loop, accelerating the clotting process. This positive feedback is a good thing, since you want blood to clot fast whenever your vessels get injured. You should definitely also leave us some positive feedback if you like this video. As it turns out, our kid here didn't fully close his book bag, and a heavy CS book is falling out and smashing a piece of starfruit on the floor. As we just discussed, the starfruit is our symbol for factor 5, while computer science, or CS for short, is our recurring symbol for proteins CNS. You know, CS for proteins CNS. So this CS book squashing a piece of 5-sided starfruit should help you remember that protein CNS work to degrade or break down factor 5. Protein C and S are both anticoagulation proteins that work to break down blood clots. One of the ways they do this is by degrading factor V in your body. Some people have a disorder known as factor V Leiden, where this factor V is resistant to breakdown by protein C and S. These people have a tendency to form a ton of blood clots, but that's a topic for another video. Next, shift your gaze to the foreground where a band kid is also prepping his ice cream here at the dessert bar. By the way, notice how this band kid also has 2 buck teeth. Yep, these 2 buck teeth here should help you remember factor 2, the next step in the common pathway of coagulation. You see, activated factors 5 and 10 actually come together to form a complex, and this combo then stimulates the cleavage of factor 2 here, activating it. Now, I wish I could just leave this at numbers, but there's actually another name for factor 2 you should know. For this, just take a look at this kid's trombone. I did say he was a band kid after all. This trombone should help you remember thrombin, since trombone sounds a lot like thrombin if you ask me. This trombone should help you remember that factor 2 is also known as thrombin. Technically, the unactivated form of factor 2 is called prothrombin, while the cleaved or activated form is called thrombin. Don't get intimidated if you see a couple different names for this clotting factor. They all basically refer to the same thing. Now, factor 2 also needs a few things for its cleavage and activation. Take a peek at this kid's calcium ice cream. You got it, factor 2 also requires calcium for activation. Since calcium ice cream is our recurring symbol for calcium, remember? Calcium ions here help catalyze the activation of factor 2. Afterwards, let's check out the membrane seal covering this ice cream. Yep, that's right, factor 2 here also requires membranes or phospholipids to be present for full activation. Let's move on. And you guessed it, where there's calcium ice cream, there's obviously also Super K going into it for that extra crunch. This Super K, as we covered before, is our recurring symbol for vitamin K, and it's here to help you remember that vitamin K is also needed for activation of factor 2. This makes factor 2 yet another vitamin K-dependent clotting factor. So what does activated factor 2, or thrombin, do next? Well, notice how the band kid wasn't looking at where his trombone was going, causing his trombone to hit this decorative doll for the dessert bar wearing a onesie. In fact, his trombone hit this doll with enough force to break right through its onesie, causing loose fibers to fall down underneath. By the way, the breaking of this onesie should help you remember cleavage of factor 1, the next step of this pathway. Yep, activated factor 2 works to cleave and activate factor 1. And as you might expect, factor 1's also special enough to deserve another name. Let's talk about what this name is. Shift your gaze down at the fibers trailing from where the onesie broke. Yep, these fibers should remind you of fibrin or fibrinogen, the other names of factor 1. Fibrinogen is the unactivated form of this clotting factor as evidenced by its -ogen ending, referring to its role as a precursor. On the other hand, fibrin is the name for the activated or cleaved form of factor 1. So if you see fibrinogen or fibrin thrown around in the hospital, just know that these are just other names for factor 1. Next, take a look at the Jell-O cup below, where it seems that the Jell-O has preferentially clotted around these fibers. You know how Jell-O needs a surface to begin coagulating into a solid? Well, these fallen fibers have made the perfect surface for clotting. As we mentioned earlier, Jell-O is our recurring symbol for coagulation, since Jell-O forms by the solidification of a red liquid. So this picture helps me remember how a blood clot is formed through a fibrin mesh, which is to say that the activated form of factor 1 aggregates to stabilize a platelet plug, turning it into an actual blood clot. This is the whole point of this entire coagulation pathway, to form a blood clot, right? Again, this is pretty high yield, so I'm going to repeat it. An activated fibrin mesh produced at the end of this pathway marks the official formation of a blood clot. That Jell-O container looks a bit unstable. It's a good thing that the shop cat has arrived to nudge it to a more stable location. Coincidentally, a black cat is our recurring symbol for the number 13, since just like black cats, the number 13 is perceived to be unlucky. So here, this black cat is here to symbolize factor 13, which acts to stabilize the fibrin mesh, forming a blood clot. Yep, just like how this black cat is stabilizing the Jell-O, solidifying around these fibers, factor 13 works to stabilize the fibrin in a blood clot. Alright, that's all we've got for the common pathway of coagulation. Let's review what we've learned. The common pathway of coagulation is the set of final steps needed to form a blood clot, shared in common by both the extrinsic and intrinsic starting pathways. This common pathway starts with the cleavage and activation of factor 10 by either the intrinsic or extrinsic pathway, in a process that requires calcium, phospholipids from a membrane, and vitamin K. Next, factor V is independently cleaved and activated by factor II in a process that is inhibited by proteins C and S. The resulting activated factors 5 and 10 then combine to form a complex, and this complex in turn activates factor II. Factor II has a few other names as prothrombin in its unactivated state and thrombin in its activated form. The activation of factor II also requires calcium, phospholipids from a membrane, and vitamin K to be present. Activated factor II then goes on to cleave and activate factor I. Factor I is also known as fibrinogen in its unactivated state and fibrin in its activated form. This fibrin then accumulates and forms a mesh. This fibrin mesh stabilizes a platelet plug, which formally marks the formation of a blood clot. Notably, the fibrin in this mesh is stabilized by factor 13. And now we're all done with the common pathway and with the entire coagulation cascade. Yet another doozy of a topic made as easy as taking Jell-O from a baby. Don't take candy from babies, folks. I'll see you in the next one.